All right, so today what we're going to do is we're going to look at our next type of equation. So we've been graphing what are called linear equations, and you know that they're linear because you don't see any exponents. Excellent, good. Which means that the graph is always going to be a straight line. Yeah? That's if it's continuous data. Yeah? Now, and for a linear equation, it's going to be continuous. So what we're going to do today is we're going to look at our next type, and that's when we have an exponent of 2, which makes it what kind of equation? Quadratic. Okay, so these are the graphs of quadratics. And each time you change the graph, you change the type of equation you're working with, you change the shape of the graph. So we're going to talk a little bit about the shape because it's really important to understand what are called the parent graphs. In other words, the basic shape. So then that way you can just make the adjustments you need to, but you know the kind of graph you're going to have. And we're going to spend a lot of time working with basic graphs, basic parabolas, and then we're going to learn how to move them about. All right? So first thing we need to know is that a parabola is simply a U shape. Okay, we'll do a little example. And it can open up or it can open down. Now they can open side to side, but you're not going to see that in this course. Okay? That just means it's solved for y instead of x. It's solved for x instead of y, but don't worry about that. Okay? It's a U shape. It opens up if your x squared is positive. Makes sense, right? Positive, open up. And it opens down if your x squared is negative. Okay. Now, so you know which direction it's going to go based on that x squared. We're going to begin with some parabolas that are in the form that you would get if you did completing the square. So you're going to see a special format for these. Then later we're going to be working with them just in the format of a quadratic formula. So you have y equals x squared, or so ax squared plus bx plus c. Remember that formula, that form? But in the beginning, we're going to be concentrating on how they move around on the graph and how you can do what are called translations. And for that to happen, we have to have them in the form of x plus or minus b plus or minus c. So, and so it's that whole bracket is squared. That first bracket is squared. And if you'll notice that this one is positive because there's nothing, no sign in front of the bracket. If there was a sign in the front of the bracket, it would be minus. That tells you that your x squared, if you multiplied out the bracket, your x squared would be negative. So that's a parabola opening what? Downward. Okay? So watch out for those signs. So you're going to see they're already in this format. And it's great when they're in that format because they are snapped to graph. Because this is called the Vertex Form. Okay? Because we're easily able to find the vertex. Now let's define that. The vertex simply is the turning point. Because if you'll look at the parabolas, the two samples I've drawn, at some point this one stops going down and starts going up, and at some point this one stops going up and starts going down. So that turning point, here and here-ish, right, on my lousy sketches, are the vertexes for these, or the vertices. So we're able to know that turning point if it's in this format. Okay? So we're going to talk a little bit about what each piece of this does to the graph and how we can then use that to be able to easily and quickly graph these. Right? So the first thing I want to do is talk a little bit about what I call the parent graph. You might not hear this expression too often here, but in the States we typically do. The parent graph means It's the start. It's the basic one. Now, then after that, you can do things to it that will make them change. But the parent graph of a quadratic is just y equals x squared. So you have a square, your x is squared, you know that means it's a parabola, but there's nothing else done to it. And the basic parent graph for a parabola means that the vertex is going to be at 0, 0, and it's a nice even curve on both sides. Now, there are ways, this is always exactly the same size. You don't care about that. It's not going to make any difference to you in the short term. You're always going to be finding some points to make that work. So don't worry about memorizing what it goes through. But it basically means that every time, because if it's x squared, what's 1 squared? 1, right? 2 squared is 4, 3 squared is 9. So it'd go through 1, 1, 2, 4, perfect squares, yeah? So do you see the pattern? And on the other side of the parabola, what you have to remember is that you get a mirror image. So if this is 1, 1, then this one is negative 1, 1. It's exactly the same distance from that axis of symmetry, which we'll talk about in just a moment. Okay? And so then the next point would be 2, 4. So this one would be negative 2, 4. And again, you don't have to memorize that. You're always going to choose some points to be able to do that. But do you see the logic of the pattern, right? And that is the basic parent parabola. Then from that, notice that we don't have anything added to or subtracted from our x squared. There's no number in front of it. So what we need to do is we need to find out what adding and subtracting those numbers, etc., will do to it. And the easiest way to do that is to first use that vertex form. Okay? So what we're going to see is, first of all, we're going to see what happens when you have a C. Okay? And remember, C means the thing that's added at the end, right? So when you have a C, what's going to happen is that's going to give you a vertical shift. Now, this is known as a translation. All of these are translations, but it's a vertical shift. And vertical means it's going up or what? Down. And so whatever your C is, it's going to take that vertex, if it's in that vertex form, right? All bets are off if it's not in that format, okay? But if it's in that vertex form, it's going to move your vertex up or down on the y-axis that many times. So if your C is 4, that means the vertex is going to go up 4. So instead of being at 0, 0, it'll be at 0, 4, right? It just moves it up and down, straight up and down. Then, and we're going to look at lots of examples of these. When you have x plus or minus b, and it's always squared, the bracket's always squared. All right, when you have that, you get a horizontal shift. So in other words, your B is going to move it right or left. Now this one is a little trickier because you're always going to go the opposite of the sign that you see. But that's easy to think about it is if you have x plus b, right? To get the b away from x, you would do the opposite. So you would subtract it. Does that make sense? If you pull a b away, so if you pull a b away from an x, it's going to change its sign. So if it's x plus b, then you're going to use negative b. So in other words, your shift is going to be moving to the left. If it's x minus b, then you're going to use positive b. Now the c on the outside is not affected by this. It's only when you pull a number away from an x, it always changes its sign. And you can kind of think of that like an equation. If we were going to get that b away from the x, we would use the opposite. It's not exactly the same thing, but it's a good mental picture of what's happening. Okay? So if you pull a number away from an x, it always changes its sign. If you pull it out of the bracket. Okay? And that is the hardest thing for most students to remember. That you have to make sure that your b is telling you you have to use the opposite direction. So if it's negative b, that means it's going to move to the left. If it's positive b, I'm sorry, if it's negative b, it's going to move to the right. Then you're right, yeah? To your right, right? Because it's going to, when you pull it away from the x, it's going to turn it into a positive. If it's x plus b, and you pull it away, it's going to give you a negative b, so it's going to move to the left. Right? And again, you're going to practice a lot of these. All right? And what that's doing is it's simply moving the vertex around. Okay? So we talk about these translations. Let's talk about the steps for then using that information to actually graph a parabola. Super easy. Okay? First, find the vertex. Now again, this has to be in that vertex form in order for this process to work. Okay? Find the vertex. Remember, C is how far it's going to go vertically. B is the horizontal shift. So all those A's and B's and C's, are just kind of taking your vertex and moving it about. Second, choose any two values for x and substitute to find y. Now this should be very familiar, right? It's just like that chart that we did for the linear equations. Now, there are other ways to do this, but for these, this is the fastest, easiest way. Now, we choose two values because we like to make sure that we're on the right track. One will do. And you're going to see later as we move forward, then I'm only doing one, and that's fine. What it does is it tells you how wide your parabola is opening. And that's all you're really worried about with these. Now, if you were asking, going to then be asked questions about it, if you had to read values, then you better choose more values so that you get a perfectly beautiful graph, right? But you're not usually asked because it's very difficult to draw a parabola perfectly, unless it's that parent one that's 1, 1, 2, 4, 3, 9 kind of thing. Otherwise, they're very difficult. You'd have to plot 10 or 15 points just to make it work. It's better just to go back to the equation and put the number in and use substitution. Third, okay, now, and when you're choosing these, I just choose positive values, usually 1 and 4 or 1 and 5 or something like that. I like values that are a little bit further apart, but you don't want to choose 5 if it's going to give you a 27 as your answer, right? Because that makes the graph too big. So you may want to stick with smaller numbers. You'll see different graphs are going to lend themselves to choosing different values. But what you're trying to do is find out how wide it's going to open. And you only need one side. Because a parabola, one side of a parabola is a mirror image of the other one. And so we're going to look at how we can use just counting to find the other side. Okay? So, count to find the other side. Now that might not make so much sense to you yet, but when you see it, you'll go, no big deal. Okay? All right. And that's all there is to it. Yes?
Is it always going to be mirrored?
Always. It has to be. A parabola will always be identical side to side. Otherwise, it's not a parabola. Okay? Yeah. Because we think about it. When you square it, say your x value is positive 2. When you square it, you get positive 4. If your x value is negative 2, when you square it, you get positive 4. Right? Does that make sense? So when you square it, it doesn't matter if it was positive or negative, it's going to give you exactly the same number. So they're always going to be perfect mirror images. And that's a good thing for you. Yeah? All right, so what I'm going to do is we're going to pop over to the book and look at a couple of these. They drag this out forever. I don't want to drag this out forever. We're going to do one where there's just a C so you can see what's happening to the vertex up and down. We're going to do one where you're just going to do a B where it's moving right or left. Then we're going to go to where they're all mixed together to do the exercises. You can do as many of them as you'd like if you think it will help, but I think you're just going to drive yourself crazy because there's like 10 pages of these. It's kind of crazy. All right? So let me just pop open the book. So let's just recap in case you're interested in looking at the way the book puts these things. So a parabola is the shape of graph when you get a quadratic equation. It's any quadratic equation. Quadratic equation is an expression with the highest power. The variable is 2. You have to be careful because sometimes it'll say x squared, but sometimes it'll give that in other formats. If you have two brackets multiplied together and they both have an x in them, you know that at some point you're going to take an x times an x, which is going to give you the x squared. Here, you have an x times another x, so that gives you an x squared. So be prepared that quadratics can be given in other forms, so you don't automatically see the x squared business. Okay? So think about if you multiplied out the brackets, how that would work. Now they have you make a table and plot points and then join the points to find the curve. You don't have to do that because it's a lot easier to find the vertex first and then choose points on one side of it and then use the fact that there's a mirror image to get the rest of them. But if you ever freak out and panic, remember I told you that chart of points always works for any graph no matter what. Right? That one when we looked at linear ones. And that's what they're showing you here. So it always works no matter what. So here's that parent graph I was talking to you about. So you see 0 gives you 0, 1 gives you 1, 2 squared is 4, 3 squared is 9. Then they chose some negative points to show you the other side. The y-intercept is 0, 0. And notice that it's an exact mirror image. So it gives you a beautiful smooth curve. Right? But notice that, now this one was drawn with a computer, so you could read values between these, or estimates of values. But if you drew that yourself, there's no way you could read estimates of values from it. It's just not going to happen. So try to draw them as accurately as you can. But if I have this point, let me show you what I mean about mirroring. If I have this point, oops, that's a terrible color to use on this. And I have this point, and I know where my vertex is, that's enough to draw a parabola. Because the vertex is the turning point. If this point is to the right 1 and up 1, then its mirror image is going to be to the left 1 and up 1. Does that make sense? So you're just going to go in the opposite direction. Now, another way of doing this is by counting, is what I was telling you. Notice that the x-axis in this case is cutting this parabola exactly in half. This is called the Axis of Symmetry. And it's a really important point, really important part of the line. And we're gonna learn a lot about it and how to find it. But it always cuts right through the vertex of the parabola. Doesn't matter if it's opening up or down. And every point on this side is the same distance from the axis of symmetry as this point on this side. And that's what I mean by counting is really easy. So, axis of symmetry here. So 1, 2, 3. So that's 3 units away from the axis of symmetry on that side, which means it has to be 3 on this side. So if I know this one point, and I know the vertex, I can graph a parabola. Right? And we typically like to pick points that are going to give you high points, because that helps you determine the spread. If you only have this point down here, then we're not sure if this thing opens really wide or if it opens very narrow. There are clues, and you'll see those later, but it's hard to tell. But if you know the point up here, you know exactly how wide it's opening. Do you see how that could be an advantage? Okay. So it just helps to choose points. So don't always choose 1, in other words, because it's going to make you're not going to know how big the graph opens. But be careful, because this is choosing 3 and it already gives you 9, so it's way up there. So it's making a pretty big graph. So you don't want to pick numbers that are too big either. Okay. So Then they talk about all parabolas are this shape, but they can be shifted, turned upside down, stretched, or any combination of these. Stretched means wider or narrower, and we're going to learn that the coefficient of the x squared is what does that part of it. Right now, we're only interested in the format and finding those vertical and horizontal translations. So if we look at this one, okay, we have x squared plus c, right? So it doesn't have the bracket, but it doesn't need the bracket because our squared is just x squared. But we have our plus c. So that plus c is going to move the vertex up or down. And in this case, since it's a positive 1, it moved it 1 unit up from the origin. You see, everything else stayed the same. It just popped it up one spot. And that's what a vertical translation does. Okay? So usually, this x squared is a bracket squared, but it can be just plain old x squared. But if you have anything added or subtracted to your squared term, when your squared term can either be just an x or a bracket, then that's your vertical translation. Okay? So what's this x squared minus 2 going to do? Drop it down 2 from the origin. All right? Now, you don't need 6 pages of that, so we're going to scroll down. Let's look at the horizontal translation. So here, this is what happens when you have the bracket, when you have a b in there. Now, you have to be careful because our b is actually positive 1. But what's going to happen to that positive 1 when I pull it away from the x? It's going to make it negative 1. So do you see we moved not 1 to the right, but 1 to the left? Okay? You're going to do that so much that it is going to become second nature. So don't panic, right? If everything you ever saw was the same as you already did, you never learned anything. So don't panic, okay? You're going to see it a lot. It's one of the basic things that happens in algebra. Okay? So let's just move down and see what they give us. So here we go. We have x plus 3 raised to the second power. So that means that's a b in there with that. So when I pull that away, it's going to be negative 3, right? Because it's positive, which means the vertex... Oops, sorry, I didn't go up long enough to see this. So that means that the vertex of this parabola, it's not going to go up or down any because there's no c, but it's going to go left 3 units. So the vertex is going to be here. And they give you a chart of values. Sorry. That's a ton of them. But we don't have to do them all. Oops. Because it's a quadratic. So when I do 1, what else am I going to know? I'm going to know negative 1. Right? Because they're going to give you the same value because you're squaring them. Okay? But, of course, you're not going to know all the rest of those. So you're going to have to just do them. But all you're doing here is squaring them and adding 3. So it's no big deal. Okay? Plot. In reality, if I had that 1 point, negative 5, I could draw this parabola. Sketch this parabola. Now, they have used so many points that it's going to give you a much better parabola than my sketch, right? More accurate. But, again, it's never going to be accurate enough for you to be able to read values from. So, who cares?
Is the vertex always going to be on one of the
No.
axes?
No. In this case, it is because we either have a B or a C. But if I have a B and a C, it's going to move it up or down and right or left. So it'll take it off the axes. And that's exactly what we're going to look at next. Mm-hmm.
How do you know that it's a B and not a C?
Because if it's a B if it's in the bracket with your x.
Okay.
And it's a C if it's just added to the square. So if you have x squared plus 4, is that a B or a C? It's a C because it's added to the x squared. If you have x minus 3 plus 2, this one is a B, this one is a C. Okay? Because this part, I'm sorry, forgot the square. Because the B is part of the square. That thing that's squared. Does that make sense? And we're going to look at a lot of these in this format. And so that's what we're going to do is we're going to go down to the ones where they're mixed together. So here's the combination, right? y equals x plus b squared plus c. So your b is always in the bracket with your x. If it's just a number added, that's always a c. Okay? So let's look at 1. There we go. Let me give us 2 of them. So the first I have y equals x minus 3 raised to the second power plus 1, which tells us that we're not only going to have a vertical, but also a horizontal shift or translation. So just name them. C in this case is 1. And our b, once we pull it away from the x, is going to be what? Positive 3. So that means we're going to go to the right 3 units and up 1 unit. Make sense? So starting at the origin, 1, 2, 3, and up 1 puts our vertex right there.
How do you find the other points?
Yeah. Now we need to find the other points. And to do that, all we need to do is just choose any x values. You're basically doing this chart again. Same. All right. Now, we want to pick a point that's to the right. I like to go to the right because it's positive. But actually, if you picked positive 1, that'd give you a point to the left of the vertex. Doesn't really matter. Okay. So do you want to pick positive 1? Do you want to pick positive 4? Do you want to pick positive 6? Does it matter? Not at all. Okay? What do you want to use?
The equation, so you do like positive 4 minus 3.
Exactly. So you want to use positive 4? So if x is positive 4, then all we're going to do is put positive 4 in place of the x and work it out, just like we did on the linear ones, yeah? So y equals 4 minus 3 quantity squared plus 1. 4 minus 3 is 1. 1 squared is 1. Oops. Plus another 1 gives you y equals 2. So you're just substituting. Put it in place of the x and do the math. Yes?
So we always draw the table of values?
Yes. Well, you need at least one other value. So you're always going to do at least one other value. Now, because if I have 4, 2, right? And up 2, so I know my parabola is passing through that point. Now, because I picked a point that is so close to my vertex, it's difficult to see how far that's going to be spread out. So I wouldn't have chosen 4 on this particular one. What I would have done was I would have chosen a value that was a little further away. So maybe x equals 1. Because it's further away from the vertex, pick something that's a few units away. Now, you could always pick more than one value. Okay? So let's see what 1 does to us. None of them are going to give you very big unless you get really far on this particular one because the numbers are so small. So look and see what happens when we solve the equation for x equals 1. Y equals 1 minus 3 quantity squared plus 1. 1 minus 3 is negative 2 squared, which gives us 4 plus 1, which is 5. So that's positive 1, positive 5, which is up there. Now that's telling us a little more about our parabola. It's telling you that it's opening pretty wide, isn't it? Okay? Now, here's our axis of symmetry. Because I have half the line, half the parabola, but I don't need the other half. How far away is this point we just found from our axis of symmetry? 2, okay? Which means that this side is also 2 units away from the axis of symmetry. So that means there's another point there. So I can draw the other half. So if you find one point, draw the axis of symmetry, and simply count how far away that point is away from the axis of symmetry, and then count across, and you'll see it, and put the next point at that same level. Okay? So what if I had a point here at 12, 0? That's 3 units away, right? Which means it would be 3 units away over there. Sorry, guys. Okay? So you can always find, so all you need is one side, and then you can just count the other side. Again, if you pick a point that's very close to your vertex, it's going to be hard to see how wide the parabola is opening. Okay? So pick a point that's further. I might have chosen 0. anyway because 0 is super easy to use. Do you remember what happens when you have 0? Your x just goes away, right? So if you can choose 0, always do it. Because watch what happens. Y equals 0 minus 3 quantity squared plus 1, which is just minus 3 squared. So 9 plus 1, which is 10. So 0, 10. So it's right there. So do you see I didn't have my parabola wide enough. But again, it doesn't matter. When you're graphing these on the test, it's just a sketch. Okay? So it really should have gone a little bit wider.
So it doesn't actually matter how wide it is.
Pardon me?
So like you have to kind of have it roughly around.
Roughly the right shape, right? If you drew this, then that would be wrong, right? Pardon?
How many points do we have to do? Like, that will make it this X?
If I'm doing this and it's a time test and I'm trying to make sure my math is right, I do 1. One. Because all I need to do is see how wide it is at the top. Because it's got to start at the vertex and then go wider, right?
Why didn't we just do like 6 and then just...
Well, because I was just showing you what happened at different points. And the book is like, they're maniacs. I don't know why they're doing 6. You don't need 6. And they always tell you to choose points on the right and on the left. Why? If it's a mirror image, you only need points on the left or the right, one or the other, because then you can just count from there. Counting is a lot easier than plugging things in. Yeah? Okay? So let's look at another one, just so we can be sure that we're all on the same page. So you see, all the format is the same. You see this, you have this bracket squared minus 5 kind of business. All right? So let's look at this one. Let's do this one. So look at number 5. We're going to graph it. And they keep giving you 2 of them to put on the same graph. So we have, look at number 6 because it looks interesting. It's not. It's just goofy format. So it's y equals 4 plus x minus 2 quantity squared, which is really just x minus 2 quantity squared plus 4. They just put your c in front of it instead of at the end. Does it make a difference? No. Anything added to or subtracted to your bracket is your c. Doesn't matter if it's in front or if it's behind. Now, is that for a c? No, that's a coefficient, so that's completely different. All bets are off, okay? So that's a completely different format we'll look at later. Okay? So, if that's the case, we first need to find the vertex by just finding our b and our c. That's why this formula is so nice, because I can just read straight from it. So our b is the number inside the bracket, but when we pull it away from the x, what's it going to do to it? So what's my b going to be? There you go. My c is anything that's added or subtracted to my bracket, which in this case is a 4, so it's positive 4. So my vertex is to the right 2, and then what? Up 4. So right there. Yeah? Just count it out like any other point. Because remember, the vertex is always the point B, comma, C. All right? Now, then I need to find any point that will tell me what the graph is doing. I don't want any point that's right next to it, so don't choose 3 or 1. Pick something a little further apart. But be careful. Negative 4 would give you a huge value that would fall way off your graph. So pick something that's at least 2 or 3 units away from your graph, from your vertex, but not too far away. So in this one, I might choose 5. 5 looks reasonable. It should tell me how far that thing is spreading, right? You don't need to know exactly. So if x is 5, then y equals 4 plus 5 minus 2 quantity squared. And again, did I tell you have to pick 5? No. It's completely arbitrary. You pick a number that you think will work for you. All right. So 5 minus 2 is 3. So that gives you 4 plus 3 squared, which is 9. So I made a bad choice here. Well, no, it'll work on this graph because they take it up high enough, right? So be careful. So 13. So that means the point is 5, 13. So here's 5. just going to go up to 13, which is right there. And that tells me that my parabola is doing that on that side. But that's only giving me one side. So here's our axis of symmetry. Do you agree? Because it cuts through the vertex. And if you count from there, that's 1, 2, 3 units away from the axis of symmetry at that point, yes? So that means it's 1, 2, 3 units on this side. Because they have to be a mirror image, which means the other side's doing that. Again, draw a softer curve than mine. Don't make this look so pointed. It's a very soft curve, right? It's just difficult to do when you're up here on this thing. Okay? Now, any questions about that one? Pretty good? Pretty happy with today's lesson? It's pretty easy. It's different, but it's easy. The only other thing that can happen to you is this business. Notice the little minus in front of your x. All right? Now, be careful. You will use it in your math when you're doing the math to find your values. But you're also going to use it to tell you that that parabola is not opening up, but what? Down. Okay? So, let's just look at one of those. Again, we still need our b and our c. B, pull that away from the x, it's going to be -1. C is that number subtracted from it, so -2. So that means our vertex is the point -1, -2. So that's -1 is to the left 1, -2 is down 2, so it's right there. Yes?
Well, why wouldn't it be +1 because you distributed the...
It's just whatever, just pull it away from your x. Don't worry about the sign on the outside yet. Now, but when we start doing the numbers, then we'll worry about it. It's just the quirk of this format. It's always just the thing. Because if you started distributing that, then it's not that format anymore. Okay? Now, so now what we want to do is just find a point. Any point. To the right or the left of the vertex. So what do you want to use? -4? Works for me. I don't care. All right? So we're going to let x equals -4. So she's chosen a point that's a few units away, right? But not so far away that you might get some huge number. And she's using a negative, but you can use whatever you want. So it's y equals -4 plus 1, quantity squared, minus 2. Now, I didn't use a bracket. I didn't need a parentheses or a bracket inside the bracket because it's all by itself, right? But if it had a coefficient, then you'd need another bracket. So -4 plus 1 is -3. -3 squared is 9. But the negative outside of the bracket is going to turn that into a -9. Minus 2 gives me -11. So my point there is -4, -11. Do we agree? Okay, just make sure you never know with me. So that means to the left 4 and down 11, so right there-ish. Yeah? So that means that this side of the parabola is doing that. Our line of symmetry, our axis of symmetry is right across there. This is 3 units away on that side, so it's 3 units away on this side. So there's your other half. It's good? Now, lulling you into a false sense of security because these are always in that format. Have you ever even seen a quadratic in that format before? Only if you've learned completing the square. It's not a very common format, but they're going to give you lots of them like that, so, and they will on the test as well. Okay? There are other formats, and we'll learn about those as we go. So let's just talk about homework. I want you to do some with their negatives, some with their positives, so we're just going to do, so I think that doing this would be plenty. If you just look at the mixing it up questions that are on page 38. So if you just do that page 38, and then that whole section on mixing it up, If you want some more practice with the others, you can go back to them. I think you're going to get enough of this. It's not really going to make that much difference. Okay? Now, again, they're not giving you a table of values here, so you can use any values you want. Just make sure that if your vertex is here, you don't want to choose 3, right? It's not going to tell you how wide your parabola is opening up. If you're nervous, choose 2 or 3 points, right? If you think you need a much more accurate graph than the one I'm teaching you, then go for it. You can never pick too many points. But remember that you have a time. This is going to be a timed exam, so you want to make sure that you do the most efficient thing possible. Okay? So you might choose 6, but it might put you up here, which tells you nothing, right? So be careful. Don't pick anything that's too big. Okay, there you go.